Okay, we are going to look at chapter 4, which is to do with the periodic table. So when you're looking at the periodic table, you will have elements and you'll have symbols for those elements. So here's an example of one on the top left hand corner. We have sodium, and it's going to be representative Na on your periodic table. All elements on the periodic table always have cap locks, and if there's any other letter that goes along with them, that's always in the lower case. So you can see the N is capital N and then the A is a lowercase afterwards. That's really important to remember when you get into writing your own chemical formulas, so that it's clear to everyone that reads your actual work what elements are in the compound that you are describing. Okay, so we have two numbers here. We have 11 up the top, and then we have this longer number that's lots of digits in it as well. So depending on what type of periodic table you're looking at, you may or may not have digits. It may be to 2 decimal points afterwards, 3 decimal points. This is an unusually long one. Or it could be rounded to a whole number. When you're doing calculations though, you can just round it to the nearest whole number, so 23. Okay. Also, depending on the periodic table, the 11 might be on top, or the 11 might be where the 23 is right now. So it's important to distinguish between the atomic number and the mass number, and know that they're not always in the exact same position. So what is the atomic number? The atomic number tells us the number of protons in an atom, or in that element, okay? So we can get into which one is which in a second. The mass number is the number of protons and neutrons in the atom. Okay? So one is just protons, and the other one is protons and neutrons. So it kind of makes sense that the ones that has nearly twice the amount of stuff in it, protons and neutrons, is going to be the bigger number. So the bigger number is always your mass number. And the smaller number is always your atomic number. Okay? So that's how you recognize, no matter where it is, if it's on top or if it's on bottom, that's how you're going to recognize which one is the atomic number, which one is the mass number. Okay, so the atomic number and the mass number don't tell you how many electrons are in the actual element at all. So if we work out here, sodium, and this is the only information I'm given from the periodic table, I want to know how many protons there are, P, how many electrons there are, E, and how many neutrons there are. So the protons is the atomic number, which is 11. Okay, and the protons is a positive charge. Okay, it's literally just a charge that has a positive sign towards it, and it creates some mass for the actual atom, and it lives in the nucleus of the atom. So here I have kind of like a little representation of them. So some of the circles are protons, and the other circles with the different color we can call neutrons. So protons and neutrons live in the nucleus, in the center of the atom. And protons and neutrons give the atom its mass. Okay? Electrons have some mass in them, but it's extremely fractional compared to the heavy, dense protons and neutrons. Okay? So that's why the mass number is made up of protons and neutrons, and there's no word of electrons. Okay? So the protons are positive. We have 11 of them. Now, if it's a neutral atom with no charges, no positive, no negatives, then the positive charges need to be balanced out by negative charges. The negative charges are called electrons. Those electrons live outside the nucleus in like an electron cloud in different sublevels. Okay, and that's a bit extreme for the amount of electrons for sodium, but you get the gist. Okay, so that they live outside on different sublevels, and you'll learn more about that as you go through the chemistry course. So electrons, if it's neutral, the number of positive charges needs to be equal to the number of negative charges. So that tells us that the electrons are also 11 because they balance each other out. Okay, now the neutrons, look at the mass number. Remember, it's protons and neutrons. So right now we have 23 protons and neutrons. We know how many protons there are, 11. And if we take those two away from each other, we're going to get 12. So 12 neutrons. Okay, and that makes sense because 11 and 12, if we add them together, gives us 23, which is the mass number. Okay, and that's how you work out protons, electrons, and neutrons. So let's just scroll down a tiny bit. And we're going to deal with something that isn't neutral. It has two numbers again, the atomic number and the mass number. And it also has a charge on it, so it's not neutral, okay? So again, we're going to do our PEN down here. Okay, so again, we need to locate which one is the atomic number and which one's the mass number. So here, I'm going to say it's the atomic number because it's smaller, and that tells us the amount of protons. This is the mass number. That's going to tell us neutrons and protons. Okay, so number of protons, 21. You can do number of neutrons first if you want. That's the mass number. Take away the atomic number. Or you can say, think of it as the number of protons and neutrons. Take away the number of protons. And that will get you 24 neutrons. Okay, now electrons, it's slightly different, so it's not neutral. There's actually a charge on it. If there wasn't any charge there at all, and what I mean by charge is this guy right here. Okay, see how there's 3 pluses? That's the charge. So if that wasn't there, it's going to be 21 electrons because there's 21 protons, and they should balance each other out if it's a neutral atom. But it isn't neutral, there's a charge on it. So if, just take a little side note, if let's say sodium has a plus on it, and sodium has a atomic number of 11, so it's going to have, like, let's say 281 if you're doing a junior cert style, and if there's a plus sign, the plus sign means that it has lost an electron. It's lost a piece of negativity is the way I like to think of it. So it's lost an electron and it's become slightly more positive. So now its electron configuration is 2,8. Okay. Whereas if we actually have a negative charge on something, it means it's gained an electron. So like, let's say, let's do Cl minus. Okay, and the amount of electrons in chlorine is 17 because the atomic number is 17. So a neutral atom of chlorine would have 17 electrons. But it's got a minus sign, which means it's actually gained a piece of negativity, gained an electron. So this guy, this ion of chlorine, actually has 18 electrons. Okay, so that's what the charge tells you. It's all about the electrons if there's a charge. So, how many electrons has scandium gained? or lost? So first of all, ask yourself, has it gained or lost electrons? Okay, so it's lost electrons because it's a plus. Okay, it's lost 3 pieces of negativity is what I like to think of it. So it's lost 3 electrons. So if it was a neutral atom, it would have 21 electrons to balance out the number of protons. But it's actually 21. Take away the 3, because it's obviously lost 3. We have a charge. And that's going to give you 18 electrons. Okay, so those 2 questions are answered. Now, I'm going to let you just look at this. This is the last little section of the video. And I want you to answer or do PEN, protons, electrons, neutrons, for all of these guys. And try your best with them. Look at the charges. What do the charges mean? Have they gained? Have they lost? Are they neutral? And there is something else in there as well. It's not going to trick you. I'll tell you after you've paused and tried it. But see if you notice anything at all. Okay, so let's start with the first one, magnesium. We know we have to locate which one is the atomic number, which one is the mass number before we get started. So this is protons and neutrons, because it's protons, because it's the smaller number, okay? So P, E, N. Protons, 12. Electrons, is there a charge on it? Nope, so it's a neutral atom, which means it's going to have the same amount of electrons as protons. Neutrons, 26 minus 12 is 14. Now, a slight little thing that's different is that the mass number, the average mass number for an atom of magnesium is actually 24, not 26. So this magnesium atom actually has more neutrons than usual, and that just means it's an isotope, isotope, of magnesium. It just means that it has more neutrons than the normal average atom of magnesium. Okay, so that's that one done. Over to chlorine, PEN. So protons, again, this is the atomic number, protons. This is protons and neutrons. So protons is 17. We can go straight to the neutrons if you want. 37 minus 17 is going to get you 20. And hopefully if we look at our periodic table, it's slightly different mass number. So this is again is an isotope of chlorine. It's not the average atom of chlorine. But the electrons, does it have a charge on it? Yes, it does. So has it gained or lost? It's gained an electron because it's gained a piece of negativity. If it was a neutral atom, it would have 17 electrons because they're positive and negative balance. But it's not neutral, so it has 1 extra electron that gives it that extra piece of negativity. Okay, down here, zinc, protons. We've got, again, the atomic number and the mass number. So 30 protons. Then the neutrons is going to be 65 take away 30, which is 35. And then the electrons, again, you're looking at the charge. So we've got plus 2. Has it gained or lost? It's lost. The normal amount of electrons would be 30, but it's lost 2 of them. So it's going to be 28 electrons. Okay, over here to iron. Same thing again. 26 protons, and we've got 30 neutrons. And our electrons, we've lost 3. It'd normally be 26 to balance it out, but it's going to be 23. Okay, I hope that's clear to you. And that's the end of the video.